Okay, so I want to go over how to get started on these frictional coefficient problems. So a couple of things I want to remind you of. This is the frictional coefficient. It's mu, and it is equal to the force of friction over the force of normal. This is not going to have any units because that's going to be newtons over newtons. So you're just going to have a multiplication factor, or a factor that you use to find the other two. And this is just a normal force diagram, which we're going to talk a little bit more about yesterday. This is the force of gravity, so that's really Fg, and it's going to be equal to mass times 9.81 meters per second squared. And this is the force normal. This is Fa, which is the force applied, and this is F of F, which is the frictional force. So those are going to be a couple of the abbreviations that you're going to see as we move through. Notice that the normal force and the gravitational force, as long as there's not any vertical movement, have to be equal. One will be positive, one will be negative, but that's just direction. The forces will actually be equal. So again, in the first one it says a hockey puck has a coefficient of friction of 0.10. If the puck feels a normal force of 5 newtons, what is the frictional force acting against the puck? Okay, so we're going to say that if mu, if mu equals F of F over F of N, then the frictional force, F of F, is going to be equal to mu times the normal force. Okay, so we'll say that frictional force equals mu, which was 0.10 times 5 newtons. So if we multiply that out, the frictional force is going to be 0.5 newtons. So that's going to be the force that's acting against that box or hockey puck, if you will. Okay, so let's look at number 2. I'm going to recopy that because I think we still need that information in order to do the next one. All right, so the next one has a couple of different steps. So let's just start at the beginning. Actually has that diagram already. All right, so if we say, suppose there is a 10 Newton force applied. Okay, so this is actually going to be this force right here, 10 newtons. It's the applied force to the side of a 4 kilogram box. So the box is 4 kilograms, that's the weight, sitting on top of a table. The block experiences a frictional force against the force applied. So that's this force right here. What is the weight, or the F of G, of the box? Okay, so this is this one right here. So we're going to say that this right here is going to be equal to the mass, which is 4.0 kilograms, times 9.81 meters per second squared. Okay, so if we do that, we're going to get F of G is going to be equal to 39.24 newtons. Okay, now because there's no vertical movement, then 39.24 newtons is going to be here, right, moving down, and then 39.24 newtons is going to be here, moving up, right? So these forces are going to be equal and opposite. So then it says, what's the normal force acting against the box? Well, if the force of gravity is 39.24 newtons, then the normal force is also 39.24 newtons, okay? Because there's no vertical movement. There's no more force on that box, okay? All right, so then let's move down to what is the coefficient of friction for this? So the coefficient of friction for this one is 0.20. Okay, so 0.20, what is the frictional force? Okay, so I'm going to go back to this formula right here, and I'm going to say, well, 0.20 equals whatever the frictional force is on top of the normal force. So that's going to be frictional force equals coefficient, 0.20, times the normal force, which is 39.24 newtons. Okay, so then I'm going to multiply that, and I get a frictional force is actually going to be 7.84, and then this is going to be newtons. Okay, so that's my frictional force. All right, so what is the next question? All right, net force. Now, net force, remember, is going to be equal to the opposing forces, right? So these are working against each other, so I'm going to subtract to find the net force for this one. So the force, applied force, if you remember, was all the way up here at the top. It's 10 newtons, right? So the applied force is going to be 10 newtons, and the frictional force I just calculated is 7.84 newtons, okay? So, did I just calculate that right? 0.2 times 39.24 equals, yeah, it's actually 8.5. Sorry, I did not round well. This is actually 8.5. 8.5, and this will be a 5. Okay, so then I'll say 10 minus 7.85, and that gives me a net force of 2.15 newtons. So this is the net force acting on the box. And then the last question for this one says, what is the acceleration from the net force? So I'm going to say, okay, well, the net force was 2.15. Okay, the mass of the box, I found out, oops, the mass of the box was 4, okay? So I'm going to say A equals force over mass, and A is going to equal to 2.15 newtons over 4 kilograms. So that's going to be, the acceleration is going to be equal to about 0.54 meters per second squared. Okay, so that should be enough to get you started. Remember that forces in the calculations are going to be an absolute value because the negative just indicates the direction of the force. So when you get down to the next problem and it says negative 300 newtons, remember that you won't use the absolute value to do your calculations for that.